Okay, so thanks for coming, everybody. It's my great pleasure today to welcome a conversation with Yuta Saito. I met Yuta just a few weeks ago in Barry for Rexus, and you're actually one of the organizers. And Yuta is an expert in off-policy counterfactual inference, particularly IPS. How do you prefer to call it? Off-policy estimation, IPS estimation? I usually call it
Uh,
IPS, but I think Dolan seem to prefer it off policy. Um,
I don't have strong preference,
no,
maybe.
no strong
Yeah, fine with either.
preference.
Yeah.
Yeah. Okay. And Yuta's a final year student at Cornell, being supervised by Thorsten Joachims, also very well-known researcher. What got my attention of Yuda's work, I think it was in 22. You did a really fantastic tutorial on off-policy learning. If people haven't seen it, it's available on YouTube, and it's one of the first things I send people to if they want to learn about it. I think it's a really, really great introduction. And you're very prolific, writing lots of papers all of the time. And something I very much like about your work is some of it is quite theoretical, but you're trying to do applied stuff. So I always like this. It's kind of where my heart lies. And you've also been a bit involved in simulations, and you've produced the open bandit pipeline for evaluating estimators, which is, I think, also a nice thing that probably people know you for. So thanks again and welcome, and it's been very interesting to learn about what you're doing. So the first question I have is, uh, what got you into what you're doing? How did you become a PhD student in Cornell? Um,
Yeah, thank you for inviting me and having me here. Yeah, it's actually a difficult question, right? To always answer. I don't remember exactly what I was doing. But let me try to summarize at least. Um, so I think I first started kind of casually studying about machine learning, statistics, and AI and deep learning around, I think it was like 2017. When I was just a sophomore undergrad student. At the time, I was studying in Tokyo, and I think that was when even like undergrad students or maybe also even high school students, if they want to, they can maybe study what is a machine learning like, what is AI. There are actually lots of great useful materials, textbooks, and also like YouTube lecture videos. More and more of them as they become available. So I was actually able to study those kind of things basically by myself. So I frankly saying I didn't rely on university lectures at all. I basically did it myself. Um, I think it's also kind of a little unique over there is that the platform Kaggle, the data science competition. I'm not sure if I'm
yes,
pronouncing
I mean, I think
correctly
most people
because
know Kaggle. Yes, of course I know Kaggle.
okay, you know it, right? Because we actually pronounce it very completely differently. Many
Sorry,
people
I
are
missed
actually,
I missed something there. You can participate in Kaggle?
um, no, I tried to actually join it because most people around me, including like students and also industry people as well, they're actually very seriously focusing on it over there. And I tried to join, but I soon realized that it was too competitive and maybe something that is the place that is maybe not good to stand out and to be unique, right? So maybe I should do something that is different from most other people to stand out. And so that's why maybe I kind of started trying to find that something that is tangible, right? That is something that is meaningful and useful, but is unique, but is different from most other people are doing. And that's maybe how I, finally identified that something like the intersection between kind of, causal inference and also machine learning can be something like that, right? So to me at the time, that is solving more like a real problem, right? You know, the 90%, 80% of the real machine learning application is like interventional to me. But
I'm sorry, 90% is what?
interventional, right? You know, we are optimizing how to act, basically.
Well,
But
marketing and recommendation are some of the bigger, at least up until say pre-LLM era, some of the biggest applications. And of course, yeah, maybe they are. I don't know how many are, because I think classic problems are not interventional or not causal. Like I think of ImageNet as the really classic problem.
yeah, I'm not sure if it's an industry problem.
Sorry.
Is it your industry problem that we care?
Wait a
For
minute.
example, are
I
your
think the most machine learning in industry is still probably in recommendation and marketing. I think. I mean, I don't have numbers on it, but that would be my judgment. And
yeah,
a
it's
lot of
really
people
subjective. Yeah,
employed on
but
things
yeah,
that may one day make money, like self-driving cars or LLMs and so on. But I think a lot of it is indeed marketing. And so
yeah, I think that's still decision making from my perspective. You
yeah,
know, LLM it's like decide what to produce. You know, what type
yeah.
of sentence to produce to maximize something to achieve some ultimate goal. Recommendation as well. So I'm not sure. Maybe from my perspective, at least, it was actually really hard to find the real problem that is purely predictional, right? It's purely prediction problem. Maybe the basic forecasting might be one of the few examples of it, but other than that, it looked to me that we are solving like a decision making problem using batch log data, but most of the people are talking about prediction. So yeah, at least that was at the time. I think that was maybe a good idea to focus on the intersection between causal inference and machine learning, or a kind of actual learning, and I might be able to be one of the first people to do research around that. And once people get interested in those areas after a few years, and then maybe they are talking to me how to apply those stuff, and that's exactly what's happening right now, fortunately.
Yeah,
Um,
I'm sure many people are interested to work out what you to maybe give you an opportunity for your next steps. But it's interesting you bring up causality because what's your take on like I must admit I'm highly opinionated on causality. What do you how would you even define causal inference? Do you have a definition of that you would say? What are the main kind of foundational ideas in causal inference?
the causal inference.
Yeah.
Yeah, maybe what I was talking about is more like the optimization side of it. You have a reward that you want to maximize, maybe the revenue, maybe clicks, maybe conversions. It's very relevant to revenue. But anyway, yeah. And then you have an action that you can actually control, whether to, deliver an advertisement or not, or what type of recommendation you want to provide. That's kind of the label that you can actually control over. And you want to optimize it in order to maximize your ultimate goal, that is the reward of your definition. And then if you want to talk about, if you want to do such an optimization, which I think is, as I said, 80% of the practice is like this, at least in my opinion. And then you need to maybe think about kind of causality-ish problem, because you need to be able to somehow compare the effectiveness, the quality, the result of different actions. But we cannot observe the kind of factors, which is something that did not happen. It could happen, but did not. That's a probabilities there. So yeah, that's maybe something that I got interested. But I think it's very different from typical causal inference, because again, in practice, of course, it depends on what type of practice we are talking about, right? Maybe if you're interested in more like a policy making, government stuff, or medical studies, I think that is more close to like typical causal inference. But I've been closely working with like recommender systems or advertisement marketing stuff. those kind of companies. And then what I'm thinking about is more like optimization stuff. How can we actually optimize the revenue or the user satisfaction via the action that we can take?
Okay.
Yeah, and that's the ultimate goal. And then on the way, we need to be able to compare the effectiveness of actions by estimating accurately kind of actuals. Yeah, so I think that's the problem that I'm looking at. And yeah, that is maybe why the interventional problem is relevant to the concept of kind of actual. Yeah.
Yeah, okay, that's super interesting. But I can't believe that. Is the journaling very audible to you? It's just happened, and I don't know what to do about it other than bear with it. But it's just stopped. But hopefully it stays stopped. But it's really annoying me if it's not doing you.
No, I'm fine. Yeah.
It's okay. All right, I'll try to mute it if it comes back. Causal inference, I find it has a slightly magical quality when it's being used because I don't think it's particularly well defined what it is. And you talked about it's more than one thing. I think like some of it is how to analyze natural experiments like in economics or nutrition and deal with confounding and these types of questions, which I think is not what you're talking about here. It's more
Yeah.
you're wanting to estimate average effects of a treatment in a situation where there is no confounding. I insist. I'm interested in your point of view, but I don't think we should. I think in the back of our mind we might say other applications. We're imagining a recommender system here. Let's say that there shouldn't really be confounding in such a system. I don't think. I'm curious on your perspective on that. And so it's not, say, do calculus and things like this, which is more, I think, to try and do natural experiments or, double machine learning and these things. That's all to do with confounding. It's not a confounding problem. It's actually you're computing average treatment effects or average reward of a personalized policy or personalized decision rule. And you seem to. You didn't say it, but I get. What's your take on the quote unquote fundamental problem of causal inference?
Yeah, I think that's maybe what you just mentioned is more like typically causal inference. I don't too much care about what is actually causal inference because what's important is to know what I want to do and then formulate it and then just solve it. And causal inference or methods might be kind of useful to approach it. That's basically how I, that's basically my thinking. But fundamental problem of causal inference, I think it should be related to like the concept of potential outcomes. And you cannot observe, I'm not sure if I can maybe phrase it correctly in English, but yeah, you cannot observe the outcomes of two different actions simultaneously, right? For individual.
Right. It seems similar to what you were saying that if you're
Yeah.
applying one treatment everywhere, then you will not see. Well, you won't see if you apply the treatment, you won't see what happens if you don't, and vice versa on an individual. I don't love elevating that to such a high principle myself because I don't. I don't really think we need counterfactuals, but that's I think that's a Bayesian take on the. Philip David says you don't need counterfactuals, and I think I'm more on his side here, but I tend to be disagreeable with everyone actually. So yeah, I mean, I think that's a good summary of your work, which is that this I think of the three leaders in the field actually. Let's say the originators as being Leon Batou, John Langford, and Thorsten. Actually, that'd be the three I always cite when I'm going to cite this general idea. And I think you've published many papers because, well, I think it's not such an easy thing, right? There's what do you see as the main kind of open questions and where you've made contributions in this type of space? Because I think there's a very simple estimator which has some interesting properties. This IPS estimator, which I see it as, well, I have a log, and I did certain actions a lot in the past, and others not so much. And then I'm going to reweight them by saying, well, some of them are going to do a lot more than I did in the past, and some will do a lot less. And so it's a reweighting of past actions and rewards. So is this the answer to everything? What are the open questions that you've
Yeah,
shed
I
light
think there
on
may
in your
be,
many papers?
yeah, I think there are two open questions in mind. One is, I think it's like estimator selection, or yeah, maybe learning algorithm selection as well. So maybe as you mentioned, there are actually many kind of factual estimators that have been proposed, right? IPS, direct method, W-robust, and I think you are aware of many other extensions of W-robust, right?
Sorry.
Many extensions of W-robust, variants of W-robust.
Okay. There are many extensions on all of them, and you mentioned direct method, which usually is in many of these papers. It's just like, to me, it gets a line. It's like that you can use the direct method, but it has bias and it's not great, and then it's just move on. But
It's true.
as I say, like I have to sort of full confession, I'm a Bayesian. I like the direct method because actually, to me, a proper Bayesian, although even this point is debatable, but a real Bayesian, I don't think can use anything except the direct method. That's
Yeah, I kind of
so,
have a pair. Yeah.
yeah.
Yeah, actually, yeah, many kind of practitioners who got interested in off-body separation, they basically have a question like this, there are like lots of methods like the abstract method that we about what is actually the one that they should use for their specific problem. And it's actually, of course, really difficult to answer in general. So I think one of the open questions would be what is actually the kind of principled way to identify what is actually the best method. Well, maybe even design a new estimator or their own estimator for their specific practice. So for example, the comparison between IPS and direct method, I think, many papers, maybe including some of my papers, basically just simply say that direct method is biased. So it's a baseline, but it's not very good, right? Always. But from a practical perspective, I know both situations, right, where IPS is much better than direct method due to low bias. But it's also true that I've seen some situation where direct method is more useful, more effective, especially for doing policy selection, not just not evaluation. If we focus on selecting which policy is better, and then we can be biased, right? And the bias is towards the same direction. If we overestimate both policies by the similar quantity, then we can still make the correct selection in terms of which is actually the better policy. And from that perspective, especially for large scale problem like recommender system that we are talking about, direct method can actually be more useful than IPS or even W-robust out of my experience. So I kind of have a fair, yeah.
When I tell IPS people that I like the direct method, they always say, "Well, what about W robust?" And but that doesn't completely make me happy because actually a Bayesian shouldn't use the propensity score at all. It's actually like they're not meant to use it, which is I think it's an interesting thing to think about why it seems useful. It's in fact I think it's one of the most kind of puzzling aspects in statistics is this why the propensity score might seem useful in some situations. By the way, at least in your tutorial, I remember because it was unusual. You actually did some simulations with the Open Bandit pipeline and showed that direct method was pretty good sometimes. And I felt quite pleased because it's often very quickly dismissed as it's biased. There's another.
Yeah, I think it really depends. So it really depends. So I basically always try to kind of correctly choose what is actually the best one. Including IPS direct method. Direct method can even be better than W-robust in some cases. So yeah.
Yeah, I mean, in some of these are sort of philosophical questions.
Yeah, true, yeah.
Like my kind of limited view of the industry is the direct method is used quite a bit. But
Mm-hmm.
something that's
Mm-hmm.
even worth saying, and I think even worth emphasizing, and some of your work touches on this, is for recommendation when the action space is crazy, crazy big. No matter
Mm-hmm.
what you say or what you think, the reward signal is not enough to work out what action to do. Like let's say you just have the simplest problem. You see a context, you see an action, you see a click, and you're wanting to optimize clicks. It's just not enough information, even in the simplest problem, very often to simply use a log of what was clicked and what was not in order to determine what to do.
Mm-hmm. Mm-hmm.
And so people use collaborative filtering, they use content, they use stuff that's nothing at all to do with the reward signal. So one of my biggest interests is to use the reward signal in combination with other things. And I see you've got work on.
Mm.
I think your paper, some of your papers using embeddings, also using
Yeah.
this
Yeah.
sort of idea. Um, I I mean, I view a little bit there's almost two branches of academic literature that have both have deltas with practice, and the other one I think is, did you see at Rexis the trillion parameter actions speak louder than words presentation?
I've heard of the title, but I don't
It's
remember what
it's
the
quite
detail.
a
Yeah.
well-known one, and it's like this. It's big paper from Meta on recommendation, crazy big networks, but they don't do any kind of. There's nothing kind of causal in their thinking. They're just built fitting models,
Mm-hmm.
basically, just fitting very
Mm-hmm.
big models. And so the emphasis is on scaling. And you see, if you like classic Rexis, movie lens Rexis has this flavor to it, which I think is less targeted at the real problem, but the real problem is very hard, which is I think what you're targeting is the real problem. Uh,
Mm-hmm.
Trying to optimize. I always say, again, I'm curious if you, this is my industry take on it. I would say, like, I want to optimize A/B test performance, um, which I
Mm-hmm.
think is similar to what an off-policy estimator is achieving, but there is a fairly big gap in practice from what
Yeah. Yeah.
it's, and I think that one thing that maybe is people that are kind of practitioners might look at these estimators and think they're going to solve their problems. And I I think not yet. And I think to me, actually, there's many open questions about how to make them useful, when to make them useful, etc. So I think it's a very
Mm-hmm.
fruitful direction. Um, so let me think. Where should we go? I can raise some of my Bayesian worries about this. I had a discussion a few years ago with John Langford. I asked a very similar question, which is, so why does a Bayesian not want to use the propensity score? Um,
Mm-hmm.
my very simple argument is, if I could divide clicks divided by impressions, why would I not do that instead of clicks divided by expected impressions?
Mm-hmm.
Which I think is a way of kind of I've taken the context out, which is kind of cheating. So in this story, but I see that if we take the context out, we just divide clicks divided by impressions instead of clicks divided by expected impressions. Clicks divided by impressions is a better estimator, I think.
Okay. What is actually the estimate that you're estimating in?
So because I want to
Is
estimate
it
the click-through rate. So should I do clicks divided by impressions or clicks divided by expected impressions?
CTR under what? Under a new policy or?
This is, I guess, the point I think is interesting is the propensity score, and it depends a bit on the setup, but it will
Mm-hmm.
often use, like, on average, I would have done this action. Perhaps I did this action on this context. I would have done it on average this many times.
Mm-hmm.
That's somewhat what the propensity score computes. And then you can look at whether you got reward, but you're looking not at the amount of times you did the action, but on average, the amount of times that you would have done the action.
Mm-hmm.
Um, that is what a Bayesian doesn't like. That thing. That the fact
Okay.
that the number of times the action was done is known but not used.
Hmm.
And the direct method, of course, does use this.
Okay, yeah. So then why not comparing the effectiveness of the method that is based on Bayesian and also non-Bayesian in your practice and just see which is actually more useful for your, which I think is depends actually.
I should go to open bandit pipeline and compare, is what you're
Yeah,
saying.
or maybe not necessarily open banded. Maybe, I'm not sure, yeah, you doesn't like IPS non-Bayesian kind of methods, which is good. But in practice, I think you know, at the end, right, it really depends, right? Maybe the method that is Bayesian might be performing better or not. So I think we can be just fair. And maybe if you believe that the Bayesian might be more likely to be better than non-Bayesian method, and then maybe you can just compare it against non-Bayesian
So
method and show
it's an
that
empirical
it's actually
question.
performing.
We
Yeah.
should let empiricism. So this raises another point that I wanted to address is, I don't know if you've seen Morris Hart, if you know Morris Hart's work, or Morris Hart and Ben Recht were recently, they were talking about the science of benchmarks. And they were very
Hmm.
pro benchmarks. But really what they have in mind is ImageNet and things in more advanced versions of ImageNet, maybe the LLM benchmarks.
Hmm.
And they they basically say like to make progress, we should just have good benchmarks and Morris Hart talks about the iron rule, which is like anything goes as long as you evaluate it and you're improving, which I think is a lot of the way machine learning works and kind of why it's fun is people can do crazy things and then they say, oh yeah, in my paper I'm improving on metrics.
Hmm.
My question is, and I'm surprised, how reasonable is this in Rexis or contextual bandits or reinforcement learning even? Does this logic transfer to these interventionist type problems?
You mean the plausibility of the benchmarking
Yeah,
evaluation? Yeah.
how valuable is benchmarking? And the how valuable in a bandit paper is the or a off policy estimation paper is the section at the end with experimental results. So
Yeah,
that
I think it's a very, yeah, interesting question. Maybe I should be careful about it. Um, so as a practitioner, I basically don't care because I think that the best method uh, for a specific company or specific application should be unique, right? So that's why I said that, right? Maybe for your application, maybe we don't know, right? Maybe the non-Bayesian method might be better, the Bayesian method might be better. So you can just compare just for your application, and then you can just pick which is better. Um, And that's basically what I do always. I don't rely on basically the existing already designed estimators because not I don't think that the authors of the papers are now designing estimator for our application, right? They're not the colleagues of us.
this is
So
yeah, yeah, that makes sense to me. I mean, I think with ImageNet, like their
mhm,
application is like other applications. That is so I think it's more meaningful. It's like, oh, AlexNet did better than other things at classifying these images. I want to classify, maybe the classes are different, but it's still a similar problem. So maybe the empirical table is quite valuable in that case.
mhm, mhm.
But what I am doubtful of, but I mean, I
Yeah, yeah, yeah,
don't agree with me all the time, by the way. It's not fun.
yeah, yeah, yeah. I think I get it.
But
I think I get the question. Yeah, yeah.
I mean,
Um,
should you could evaluate with open bandit pipeline, you could evaluate with using the supervised bandit transform. Do those tables of results help me answer whether I should use it, I suppose is.
I don't think so necessarily, but as a research paper, the authors should at least show that there is a scenario where the method can be better than the baselines. there is at least one scenarios and show when it's actually it's better, it's superior to the other method that was available at the time. But as a practitioner who I just reading the paper, I don't think that the experiment setup and even the formulation of the paper is relevant to the application that I'm working on. So I just try to understand the high level idea. For example, there are estimators using some type of assumption like cascade assumption or linearity assumption for the storage papers. But my understanding of those papers are like, okay, we don't need to necessarily write on the assumption that was exactly proposed in the papers, but what's actually important to understand is that if we have any assumption that's reasonable to our application, and then based on the assumption, we can design our own estimator based on the assumption. And of course, the resulting estimator doesn't have to be something that is existing in the academics. We don't care because we are designing our own estimator for application, right? So that's basically my understanding. So I'm not sure it's kind of neutral. I don't know, right? I don't think that the tables that you mentioned that are not necessarily relevant to the specific application, but as a research paper, I think it's kind of necessary, right, for them to show at least it's useful in some of the situations.
I mean, yeah, I think the tables exist for two reasons, and like one is maybe an empirical claim that I can learn better, and I think in ImageNet with it's these probably have claims, and then the other is this. I did some work. I showed that I can, I implemented
Yeah.
it. It's valid. I debugged the code, but. I mean, I kind of have a related question then is like, if you're reviewing a paper, do you go first to the results section or not? Is it if you're wanting to work out if the contribution is good?
Sorry, do I need an experiment section first or?
Yeah, do you turn straight to the experiments and see if their algorithm is being bold in all the tables? Because I
In my
think
case, no,
a
yeah.
certain subset of reviewers do it this way, and another subset almost ignore the table. Like I think it's what should a reviewer do? Like what advice would you give of trying to work out if the contribution is worthy or not?
Yeah, may not necessarily be advice, but what I do is basically just focus on the formulation that and understand what they want to do, what's the unique problems or issues that they are solving, and also the method as well. And I do not completely ignore the experiment section, but I lead it at the end.
Okay.
Yeah.
All right. I think that's kind of where I see it as well.
So that comes last. Yeah.
I mean, I think you're in a very clear in some applications. I'm sure it's fine to go straight to the experiment section if it's a very well-defined metric on a very well-defined problem that has very clear value. But it's
it really depends. Yeah. I think, but I think you can imagine that, right? I basically review like policy evaluation or treatment effect prediction, funded papers. So I think I should be careful of what is the quantity that they're trying to estimate, and also what is actually the evaluation criteria of their estimators, stuff like that. So that's maybe why. So yeah.
Yeah. Yeah, I mean, definitely these are problems that you can present in papers that simplified contextual. Most real systems are not really contextual bounded. So there's the action spaces, many actions are delivered at once, etc. So I mean, maybe we should talk a bit about what you think are the main kind of lackings of the vanilla IPS, where progress has been made and where more progress is needed.
Yeah, not just IPS, but maybe a bit broadly about contextual bounded or policy learning. That actually, I think that is a little relevant to what I was doing at Reflex at a high level, at a very high level. What I've been recently pretty much interested in is how to design what to optimize, rather than just how to optimize it. So again, right, many papers basically are talking about how to optimize something. including many operative learning papers. Okay, we are talking about, for example, like expected reward and then how to maximize it using the log data that was collected on the previously deployed policy. That's basically most policy learning papers are talking about. But in practice, I think that one of the hardest question would be that what should actually be the reward to improve user satisfaction?
Okay.
Yeah, or maybe the long-term revenue of the company. Yeah.
And if we go back to my favorite example, recommender systems, are you saying the reward might not be clicks?
Yes. Yes.
To me, there's always this funny paradox when you're working in, say, clicks or in recommendation or advertising, which is everybody knows that the real reward is not clicks, and then how do you optimize something else? What if it's not clicks? What do you think it might be? Like, what would you target other than clicks?
Yeah, there should be many, right? The diversity or the play duration, likes, sums, and there's also subscription. Yeah, I think it also depends on the application, but
In
yeah, right. The
advertising,
application.
it's somewhat easy for us because we have, I wouldn't say it's totally easy, but we are trying to optimize money at some level, like sales and things like this. So it's something that I think puts us in a kind of clearer position than some people like YouTube or video delivery or Spotify, etc. They're not so obvious what they're wanting to do, but for us, we have dollars involved in some way in the system in some way, so that becomes clearer. But what is to me the tricky thing is that the money is. We discussed this slightly before we started, but there are multiple recommendations delivered to a user. So the contextual bandit is not such a bad model of a click, but it's not a great model of a sale. I don't know if you've addressed these types of questions where
I think kind of, yeah. So the problem that we are talking about is more like, the subscription service. And what does it mean to optimize, improve user satisfaction? And that is something that is not directly optimizable. So we need to define some reward that is attached to every single recommendation or session. So it may be relatively easy to just optimize clicks or play duration, but that may not directly connect to maximizing user satisfaction in the long run. So what should actually we optimize or use a reward as a bandit system so that we maximize user satisfaction or the yearly revenue of the company. Yeah, ultimately, yeah. So that's.
I guess this is a Netflix problem. I think Netflix have a model where they build a model of that someone might leave the service and they try to prevent someone leaving the service. But this strikes me also as extremely difficult to, not for just the reason that there's sort of many recommendations delivered to the user, but I have to admit I've never thought about this problem because it's not an advertising problem. What does someone look like when they leave the service and how to prevent them arriving there, I guess is the goal in this case.
But yeah, it's extremely difficult, but without defining what to optimize in the first place, we cannot talk about how to optimize, right? Because we are not sure we are actually doing the right thing. Yeah, of course, both are important, but people often basically talking just about how to optimize. Because again, thinking about what to optimize is very problem specific. And I think it's too specific to talk about as a research paper. So there's not many papers talking about actually defining what to optimize in the first place, which I think is reasonable. But
have you at any time encountered attribution, the attribution literature, which I think is more aligned with marketing? And it's not good on it. Like, I think there are people in computational marketing that would say it's the biggest unsolved problem, but I don't think it's solvable. So it's more or less, did the click, which click caused the sale type, which is used in billing. So in computational advertising, sometimes if a click is followed by a sale, that will be billed. But it's probably didn't cause the sale. It's a much more complicated question. Maybe the sale would have happened anyway, or maybe an older recommendation influenced the sale.
Yeah, for the application, I'm kind of interested in asking this. So maybe you can think of two different rewards, right? Clicks and also conversions. And conversion might be a more ultimate reward that you want to maximize compared to click. I think it also depends on the vision structure, but maybe it's also reasonable to think about, you want to ultimately maximize conversion rather than click. But click might also be a kind of useful auxiliary information that we could use as a type of reward. And maybe when we build a prediction model, maybe we can use both if we want. So the question is, what is actually the best way to combine the click signal and also the conversion signal to build a best prediction model? Is it a relevant question to your?
Exactly, but what is when you do a recommendation, it's either clicked or not. But a sale is actually doesn't belong to the recommendation. It just happens somewhere. And so that's a really fundamental difference. Now you could, you could actually use like an IPS off policy estimator here on the whole sequence, right? You could do this. It's going to have horrific variance because as soon as there's interacting actions, but you can do this, and it's actually one of the settings where it's hardest to do Bayes, as I mentioned before, when there's multiple interactions with the user. So it's maybe one of the situations where I don't have a good alternative to doing off policy estimation with IPS, even though I would always like to use Bayes. And so it's a situation where we have used it actually in this context where there's many actions being delivered in order to kind of diversify the recommendations for, say, the delivery of sales and things like this. Because the diversity is not something, if you have an idea that you need temporal diversity, it cannot be handled with a contextual bandit by design. Like it's not possible, right? But we know that showing the same user the same thing all the time is not a good idea. So this is one of those places where I have no really good alternative to off policy estimation. But I've also when it's happened, it has incredible variance for understandable reasons. And usually we've not been tuning the individual recommendations, but a single parameter that will control that diversity.
Yeah, so maybe what I was doing or I've been thinking about right now is, so as you said, let's take diversity or accuracy diversity trade-off as an example. And then what is actually the best trade-off? And that might be actually different for different people, different users, some type of user may prefer diverse recommendation. Some other people may not, right? They want to just have accurate recommendation because they don't want to search by themselves. So,
yeah, absolutely. But then personalizing diversity is going to be an extra complication again. Once you personalize something, it's of course going to make it harder. But yeah.
Yeah, I think but yeah, that's maybe something that I frame as an interesting research question. What is actually the impact? If there's impact, maybe maybe we can start thinking about. Also, we don't need to do it at every different individual level, right? Maybe we can just think about a few cluster of users and then start personalizing at the cluster level, for example. And that is already maybe better than doing no personalization, just do the same level of diversity for every people. That's the baseline. So maybe we don't need to think about the individual level personalization at first, maybe. So yeah.
Yeah, for sure. I think there's many options, but it is kind of the curse of personalization, which is it's um, it can be pretty hard to do it when if treatment effects are small. Like it's as you personalize, everyone thinks it matters, I think, but it becomes very difficult to
Yeah, true, true. Yeah.
personalize small treatment effects. Um,
Yeah, especially, yeah, I totally agree. Especially when we are thinking about kind of the long-term reward, and then, the sensitivity is very tiny, I'd say. So yeah, it actually comes down to the level of personalization that we do, right? If we do like the personalization at every individual level, the individual level personalization, and then that would be kind of very difficult, learning program. We need to be actually able to capture the tiny sensitivity of the long-term reward to be able to effectively optimize. But if we just think about two different clusters and then use different level of diversity for each, and then that is something maybe solvable, right? Especially even if the long-term reward is not that sensitive. So I think there is also a kind of interesting trade-off of how much personalization we can do versus the sensitivity of the reward, or maybe the controllability over it by our policy or action. So yeah, that's kind
this
of
is
also.
this is one of I have a few concerns about the way that,
Mhm,
if you like, the way it's presented often, which is the supervised bandit transform. So
mhm, mhm,
just to explain what that is, and let me try to explain it and you can correct me, is you take a standard supervised learning problem. So it could be MNIST or something like this. And then you give the features of the problem. You give an action, which could be either the label, the true label. So like say you're putting in the pixels of say the 0, then you're saying, well, the action is a 1. And then you will say, well, this is a 0 reward because they don't agree. But if you put in the action as a 0, then you get a reward here. So
mhm,
when comparing to recommended systems, there's two things about this that are not very realistic. One is that the
mhm,
number of actions here is pretty small, and the other is that the treatment effect is very big. You have one item that's very good, and all the
mhm,
just giving a reward of 1. And so once you bring into click-through rates and things like this are a few percent at the most. Um, so this is, I know it's the tradition to evaluate the papers like this, but
yeah, yeah, yeah.
I I mean I think maybe the open bandit. What's your take on this? Uh, how should recommended systems people look at this kind of contextual bandit literature, these evaluations in light of the differences between the problems being evaluated? And
So you mean paper is fully
I, I
derived on
don't I
the.
don't ask you easy questions, you know. But
Yeah.
how do
So
we
you
how do
mean,
we how do we make these evaluations more realistic?
yeah, I think that pretty much crosses our previous conversation, right? Where we talk about what is actually the, I don't know, how relevant tables are, right, in a paper to the applications practice.
Yeah, exactly.
Um,
But it's
yeah,
so I mean maybe simulation is a good um
simulation is good if you design by yourself for imitating your application, right?
I mean I
So
can tell you what reviewers say when we evaluate by simulation, which is of course it's of course because you control the simulator you've got a good answer. That becomes the problem though. Um
mhm. Okay. So as a research, no, I mean, are you trying to interpret the experiment result or section as a
Yeah,
reviewer,
you're
or?
right. It is returning a bit to the topic we talked about before. If the off policy, or if I'm wanting to do something for a recommended system where I have a million actions and the high CTR, the CTRs are all between 2% and 1%,
Mhm,
then how that to me is a fairly classic setup in real
mhm,
life. It's quite far. I mean, I'm just saying it's quite far from, say, a supervised bandit transform as an
Yeah, yeah.
evaluation.
Hmm.
Um, okay, I can be just. It's all right for you to say I don't know, but I wish there was a better
No,
evaluation
yeah.
of that type of situation.
I think, yeah, I think it really depends on who you are, right? If you are reading a paper as a practitioner, then you don't need to. It's very rare that the experiment setup that is written by the researchers who are not the colleagues of you is relevant to your application. So again, maybe if you're interested in the empirical effectiveness of the method, then I think what we need to do, or ideally, is to design your environment, your simulator that is imitating your application of interest, and then try the method proposed there. Um, right. But
I,
again, right, other
yeah, I mean, I think it's a reasonable thing to do to make a more realistic simulator. I don't have a good
yeah,
answer, and I don't. Well, I asked a similar question to Darwin, and he was a bit like, yeah, academic and practice are different. That's just the way the world is. So maybe that's a pretty good answer in some way. But
yeah.
as
I think
someone
it
that's,
also depends.
I would like them to be closer, but yeah.
Yeah, I think it also depends on what is, I think, your strategy of how precisely you want to evaluate your method for your application. It depends, right? I think the ideal thing is, you don't do any experiment, you don't do any simulation, but you can actually answer what is the best method for your application. Depending solely on your brain, that's the best thing, right? But it's not always the case, right? We don't know which is actually the best estimator without using any data, without using any simulation. And you want to be precise about it, you should take your time to do it. Uh, so I think comes down to the problem of kind of prioritization, of your work, right? Or yeah, but as a researcher, again, right, yeah, of course, it's not always relevant that the experiment that you're performing is to, that you practice, specific application. That's true. You are not writing a paper for a particular company for a particular application, right? You are talking about the method in a general fashion, and just show that there is at least some scenarios where your method is more useful, or just identify when is actually the method is superior to the
Yeah, yeah.
other. Yeah. So of course there should be
I,
some type
I
of evaluation in terms of the experiment section from that perspective as well. But yeah, I think it really depends who you are, and how you want to use a research paper too. Yeah.
I think reviewers have very different takes on that. And so, I mean, some reviewers have never seen
Yeah.
the problem, and some are very familiar with them as well. So that's a
Yeah.
that's an item here.
That's
Yeah.
that's basically why I recently don't care about the review evaluation. I mean the score. I of course did the review test very carefully, and if you have some useful suggestion, I will use them to improve my paper, of course, or presentation. But I don't care too much about if the paper is accepted or not. What is important is to do what I think is valuable, what I think is useful, and ensure what I think is uh, you know useful to demonstrate. But of course, reviews, they're diverse reviews, right? We are reviewing
Yeah, that sounds like a
10,000.
super healthy. I mean, I do get annoyed with the reviewers if and sometimes I think I get most annoyed reviewers when they're right. So that's the worst because you don't have a kind of response. But I also get annoyed with reviewers when I think they're wrong. So um, I might throw out just one other kind of like difficult question, which is one reason I think IPS methods look good in certain settings is they cling to the logging policy. Do you agree with this criticism?
Sorry, going to,
They cling to the logging policy.
sorry, what do you mean by that?
What I mean is that the logging policy is probably quite good. I mean, obviously in an experiment, it's somewhat artificial, but
Hmm.
the logging policy should be delivering mostly good actions.
Hmm.
Now, this let's say you've got an IPS estimator. we can even make the logging policy epsilon greedy, right? So it's going to do what it thinks is the best action most of the time.
Mhm.
Now, if we're going to learn a new policy, there's kind of like the question, will it move off the logging policy or not? Because it will probably
Mhm.
produce pretty good estimates of the CTR on the logging
Mhm.
policy. But
Mhm.
if there's an action that it could have done but didn't, a
Mhm.
standard IPS estimate, nothing special, it will estimate that the reward is 0,
Mhm. Mhm.
which usually is considered bad, right? If you could have done the action but didn't, you estimated it, the estimate comes out at 0. So it will avoid those actions.
Mhm.
Um, and this causes like clinging phenomena where it clings. So that sometimes there's like extra pessimism and other things added in, but even the vanilla version, I think in the normal setup, you can actually set it up to do the opposite. You can make 0 good, and then it will pull away from the logging policy. But in the normal setup, it'll cling to the logging policy. And as the logging policy is probably not that bad, it makes it's advantageous to the IPS estimator.
Yeah, so I think it is more about how stochastic the logging policy is, or how exponential the logging policy is, right? And also how close the new policy that you're evaluating is to the logging policy. Is it the correct understanding of,
Sorry.
I mean, if you're performing epsilon greedy, I mean, if your logging policy is epsilon greedy, and then I think it's close to kind of uniform exploration. Of course, I know that it's not exactly uniform, but it's close, kind of, compared to the deterministic logging. So I think that's basically why IPS is relatively favorable there, because you have lots of stochastic in your log data. So there's lots of
I actually think epsilon greedies are really hard to learn off. Uh,
mhm,
if I put it this way, I have my preferred action, and let's say epsilon is 0.1. So I'll do the preferred action 90% of the time. And
mhm,
say I
mhm,
have 1,000,001 actions, then all the
mhm,
others, the probability of pulling that arm is 1 on 1,000,000, which is super low.
mhm.
And so actually, and I'm leaving the context out, but
Yeah, yeah.
but the probability of pulling that arm is really low. And so mostly you're not even going to pull them once in most cases.
I think it's not.
Mostly you will just not pull an arm.
So you said that there are million actions, right?
Yeah, let's say there are 1,000,001 actions.
Yeah. And then I think that's not just ipsum greedy, right? Basically every other login policy should have a similar kind of problem, right?
Yeah, for sure. That I'm just saying this is a
Yeah.
thing to learn off, because
So
really what you get is you either get your preferred action or you get
mhm,
another action which you never tried. You get another action that you never tried and it didn't work, or you got another action that you tried and it worked, which would be quite rare, but it will still happen sometimes.
mhm,
And then to me, there's a question of like, well, should you move off the logging policy to those actions that you tried once and worked?
mhm,
And I think usually the assumptions are, well, we'll cling to the logging policy, but maybe you don't in these instances. That'll depend a lot on the properties of the estimator, whether you move to
mhm.
that one or not. Um, that's a standard way I think about it, which I think is not the classic way at all.
Yeah. Yeah, I think it's a typical large action space problem, and it's not a good way just to apply the typical estimators there, right? If you can remove it, many of the ineffective action, if you know some type of prior knowledge, well, maybe you can use some type of direct method for the purpose of removing ineffective action,
I agree. There's
and
not much you
focus
can
on,
do in
yeah.
this setting, by the way. I'm not saying a Bayes will save you here. I mean, I think you've worked a little bit on two-stage systems, which to me, what it kind of does is, you have candidate generation and then you don't use
Mm-hmm,
the bandit feedback on the candidate generation, and then you concentrate the bandit feedback on a small set of actions. And I think it works
mm-hmm.
in that setting. And that kind of, I think, is quite heuristic, but I think it's kind of what happens. in practice. Because I
Yeah, yeah,
think that bandit feedback across the entire action space is not usable, actually. Not really. You need to pick out. It's probably better just to guess a priori for using embeddings or something else. Probably one of these 10 actions is good, and then collect bandit feedback only on these. But because I just
yeah.
don't see
I
no
think so, yeah,
answer to such a situation.
yeah. I think so, yeah. That's why most industry recommend a system are indeed like multi-stage or two, right? I think you're referring to like the two-stage or multi-stage.
Yeah,
Recommend a system of like candidate stage, and then there is the ranking stage, right?
exactly,
Um,
exactly. Yeah,
yes, but still, it's maybe a problem where even if you focus only on the ranking space, that might be large scale compared to many academic papers. So
yeah.
maybe you should do something there. For example, using actual features or maybe combining different estimators to deal with.
I
Yeah, it really
agree. It's
depends on,
messy, right?
yeah,
It's messy having one stage with one criteria and another stage with another. I
yeah.
think, yeah,
And
that's
legal
one of the
is,
most.
yeah, I think this may not be very relevant to practice, but legal is saying there's also kind of interaction between the first stage and the second stage. So the effectiveness of the second stage, the effectiveness of the candidate generation policy is actually different given different first stage policies. Different re-ranking policies. Um, so the performance of the candidate generation can be actually different given what is actually the ranking policy under it. So yeah, that's actually also the leaders understanding of it. And if I think write a paper about policy variation of such multi-stage bunny policies, maybe that's something that interesting topic to explore as a research paper. But I'm not sure if this is really you know impactful or has an effect impacted. Yeah.
I think it's impactful because it's how many systems really exist, and you end up with uh, lots of kind of heuristics. Like one stage is optimizing one set of criteria and then feeding into another. This is what real systems look like. And
Yeah, yeah.
so I think anyone that can kind of clean this up in a way that's useful, I think is going to actually make big impacts. It's something I would like to do, but it's kind of combining. I mean, your paper around using embeddings from a couple of years ago, I think it's partially mixing these ideas. I think it's uh,
Yeah, but the formulation, of the paper is more like general, right? It's not focusing on two stages. It's more like a general, large
no,
scale. Yeah,
absolutely, absolutely. But the first stage could be, you could imagine you have a two-stage system where the first stage is based on the embedding, say, and then the second stage, you will still have the embeddings. You may as well use them type of idea.
yeah,
Uh,
true, true. Yeah. That is certainly relevant. Maybe what I was mentioning is like, maybe there is also a unique, interesting program regarding like the multi-stage recommendation. I think there are maybe both motivation of, maybe we want to estimate the new candidate generation policy, but the second stage policy is fixed, right? It's a login policy. And we want to just, want to estimate the performance of the new first stage policy. Well, there's also maybe a realistic case where we change both stages, right? We want to deploy new first stage policy as well as the second stage policy, which is also new. So we
yeah,
want to evaluate the effectiveness of the entire system. And then rigorously saying there is an interaction between first stage and second stage. I mean, the best first stage policy may be different given different second stage policies.
it,
So
it's actually a lot harder, I think, when you're only
yeah, true. Yeah.
working on a subsystem. So I've spent a lot of my time working on the candidate generation part, actually, not the.
Hmm.
But what I tell myself is I imagine it's the frontline system, and I tell myself,
Yeah.
but it's
Yeah.
not necessarily the case. It could be that you're advancing a candidate that is actually a bad, and you're better off holding it back because the frontline system likes it, but it's not good. Like could theoretically
Hmm.
happen, for
Yeah.
example.
Yeah. Yeah.
And
Yeah.
what is another ugliness of reality is there are often numerous parallel candidate generation systems. And so you
Mhm.
also need to think about whether your candidate system is overlapping with another one, and it could fail simply because it overlaps, for example.
Mhm.
And so maybe if all the existing systems are good, but then now you actually have a much more complicated problem, I think. But I don't really like the problem because it's just messy. I'm not sure this would make a good academic paper because this is very messy now.
Yeah, that's probably why I say, like, the rigorously say, right, there is a problem of interaction and how to actually deal with, the relation between first stage and second stage, but it really depends if you should work on this in practice, right? If it's impactful, and then maybe you should do it, but it's not that impactful, and then you just take your time. So
yeah.
if you can ignore it and focus
Well,
on
you'll
improvement.
have time, I'm sure. Well, maybe because we should wrap up, I guess. Do you know what you're planning to
Yeah,
do
yeah, yeah.
next, or are you going to work for a company one day or doing this type of work, or do you have more plans to be more a research, like academic research scientist?
I think it's likely to go for industry after graduation in the US, but what's maybe a little unique for me is that I have also a lot of company, industry connections over there in Japan because, I am fortunately,
Okay.
and maybe I was maybe about to say it, in the first part, but, I was maybe fortunately one of the first people focusing on this area of, kind of factory expression and learning. So when a person or company is interested in kind of factual thing, and then I'm actually one of the first people to talk to.
I can
That's kind of
imagine there's a lot of
interesting.
opportunities, yeah.
Yeah. So actually, over 10 companies are talking to me about how to apply this type of policy evaluation and learning, and also the design of the reward function. Um, so yeah, I want to also take advantage of that interesting situation as well. So yeah, maybe I will continue it while working on, the problem by myself, by my hand here in the US. So that's maybe one of the blueprint that I'm imagining. Yeah.
Okay. Yeah, that sounds really fun, actually. But
Yeah. If I don't
you
do
should definitely
anything, then
visit us if
maybe.
you're ever in Paris.
Mhm.
Anything else you
Yeah,
want
yeah,
to
yeah.
point people to? There's the Open Bandit pipeline. Any paper you want to highlight that you think people will enjoy?
Yeah, I think we are, I mean, with Darwin and also some other folks at Netflix, we are actively working on the problem of, again, designing what to optimize or
Okay.
designing reward function in a data-driven fashion. And we are writing a paper, but I think that should be published sometime early 2025. So if you're interested, maybe that's something that,
I'm super
yeah,
interested. Please tell
yeah,
me what it is, and maybe we can talk again about it when you've
yeah.
written.
Try to present it at next Brexit. So that's my,
Okay,
yeah,
that'd be
that's my,
awesome.
yeah.
All right. Well, thanks again. I'll let you know when the recording's out, and I really appreciate your time. It's been fun.
So thank you. Yeah, it was super fun.